I say we continue into, say, the whole notion of where we're at on channel programs and libzfs and libzfs core. We have some very key people within reach. Welcome back. But Rob, what's quiz? Can you tell the group what quiz is? What's quiz?
uh, Having the whole presentation. It's basically, it is a VM. It's a tool I wrote to. The idea is to spin up a VM, in a couple of seconds, and to act like if you're prototyping your programming, like the scripting language or whatever, you just you write the program and you run it and you see what happens, and it crashes, or you just hit Control C, or it spits out a whole bunch of stuff, or you want to test something and you spit out a whole bunch of output and then you pipe it into grep and that sort of thing, and you just do it on your laptop. And then because it's a process, when it dies, it's gone completely. I wanted that for ZFS development. Because I don't have much hardware, and because iterating on a VM in a VirtualBox or whatever, or moving your code into a VM or crashing your own machine or all that sort of thing sucked. So I wrote a bunch of shell to build a very minimal Debian-based system and Linux kernel config, and then QEMU config that will spin up really quick in a few seconds. I can develop on my own machine with my own tools, and then install ZFS into it, and then I can boot it. It'll run a script that sets up a pool, does whatever it does, just on memory-backed file systems. Output goes to the hosts standard out, so that I can just I can put kernel log lines directly into the ZFS code, have it print out stuff, which I can then grep. And when this VM dies, it's gone. It's completely ephemeral. There's no leftover on disk bit. There is, the single image that is shared between each run. And so that's kind of the idea. So the idea is to kind of make kernel development feel like just local development on my laptop. That's the whole thing. I did a talk at BSDCan last year, 24, which is on YouTube, and if you ping me directly, I can send you some notes. It's github.com/broadband/quiz if you want to look more. It's not a ZFS specific tool. I use it for ZFS development. It's got a couple of little helpers in there to help me with that, but it's really a sort of a kernel dev helper. That's what quiz is.
Cool. Any questions from the audience about quiz? I thought it was a great use of all those tools. Go ahead.
Well, how is it different from Vagrant with KVM back? At all? Just different?
It's mostly just stripped down to be what I need. You could probably do it with that. The really fast boot time, the boot to shell effectively within 3 to 4 seconds was critical, because if I have to wait for something, I'll forget that it's there, and then I'll forget to come back to it. So that was the main thing for me. And then to disappear without a trace, so no real disk or disk image. But I mean, you can probably do it in lots of other places. Like I say, it's just shell. So
you're making me laugh because I just forgot that I started a Vagrant. So
yeah, right. But see, it needs to be done before I get bored and change to another workspace and go and read something, because then I'll never come back. So that was the main driver.
That's just like if your Ansible playbook takes 5 minutes instead of 5 seconds, your attention wanders away.
Yep.
Cool.
Yep. I'm proudly ADHD, so yeah. I bounce around a lot, sometimes by force.
So it's an ADHD medication for file system development.
There you go.
Got it. Thank you. I've done, somewhat crudely, my best attempt to summarize the discussion in this very room last year, which, correct me if I'm wrong, libzfs is a private library, full stop. libzfs core does a few things that a few people want, and libzfs.py satisfies some users, and you may actually want channel programs for what you're doing, but they don't do all the things. And here we are. I'd love to know if anyone's made progress on that since then, and Jan, who I believe is on the chat, has kindly identified the 4 to 6 files that one truly needs to depend on, and massaged a make file to make use of them for a private C application. And, well, as long as the rug doesn't get pulled out from under that, it should work just fine. But I do want to nuance it with something on the board, which is a notion of either a channel programs repo, or how'd you describe that? But does anyone have news to report from last year's discussion on this? Or are we at the same crossroads of like, well, you can want nice things, but we're just we see it differently, or something, or write it yourself, no problem, and maintain it yourself, and off we go. So, Rob, you've been very helpful in describing the problem, and you've produced a lovely blog post on that. Let's bring that up. This is since the discussion last year. Labs, presentations, quiz, but sparelabs.com, and that was somewhat better. So, has anyone not seen this blog post? I thank you for capturing the state of affairs after the meeting last year. Rob, can you summarize this for the group, as I've taken my stab at it, but I am by no means a kernel developer?
So the reason we've been talking about this in the production user calls on and off through the year, and the reason is that I just want to sit in a post, there is desire for programmatic access to ZFS and to ZFS control facilities. So, creating a data set, creating a snapshot, those kinds of things. Something sort of, I suppose, more structured than calling out to executing the ZFS program. And, there's a long way we can go now. We have JSON output, so it's easier to disambiguate some things in the output, which is very nice. But there is still overheads in every syscall doesn't remember the previous one. So if you've got kind of a wider context, there's still issues where, like, if a step fails in between, then how do you get back to a consistent state? Or, so being able to say, I've got this whole set of changes that I want to make, go. So and then this just reviews the options that we have, which is the things people try and reach for. So libzfs is the sort of internal library that underpins the zpool and ZFS tools, but it's very much, this is an internal utility library. This is not for general consumption. It should never be for general consumption. And I mean, and it has its own reasons. It has its own reasons for existing, but it has some quite high level concepts in it, and so people are drawn to it because, like if you are doing, the raw ioptals and you want to do a particular task, like say, a simple thing. Right? I want to list all the data sets. You actually have to make multiple calls into the kernel. Which means you have to make multiple calls. You have to know what you want to do. You have to know how to do those things. Some are simple, some are not, some have weird arguments, this sort of thing. So it is sort of, people are drawn to it because they're like, oh, I just want to say, verb noun, or, create data set. Just, destroy, pull, whatever. So then anyone looking might look towards libzfs core, which is kind of the blessed committed interface. This by design is each function is a wrapping around a single ioctal, which is and has a sort of a common interface with like arguments and responses through NV lists, which are basically, just think of it as a KV. They're basically JSON. But programmery, they're fine. This is nice that it exists, that it's a committed stable interface, but it's you still have to know which moving parts you have to touch in which order, and how to construct the arguments and all the rest of it. So it's fine. And it hasn't been fully filled out, so we can't do everything that a person might want to do. That's just a matter of time. Like, we could fill out all those could and should fill out all those pieces. Just no one's done it yet, which isn't useful for people turning up wanting to do things. There is Python bindings, which I can't remember what their bindings to. I think their bindings to libzfs core.
The bindings
But-
to the full libzfs and the libzfs.h header acknowledge the existence of the Python bindings by telling to always keep them in sync in the C.
Oh, yeah. Okay, they're bindings to libzfs. Okay, it's the same. But either way, they'd be the same thing. And they're just used, we just ship with those because they're used for some of the internal tools like your arcstat and that kind of thing. And
I guess I have a
They're-
question.
Yeah.
So, obviously, part of the problem comes from people want to consume libzfs because it has the richer interface. It's how, if you do it the libzfs way, that's the same way that the ZFS command line tool works. The problem being that, it's not a stable interface. It changes every time we change something in ZFS. I've been guilty of changing libzfs a couple of times myself. But I do wonder if something akin to symbol versioning could solve this here. If we kept the version of the function from 2.3, and when we made a change to the function in 2.4, such that a program linking against libzfs could say, I expect the 2.3 interfaces, and is still able to work, and we solved the problem of, hey, my tool that was built for ZFS 2.3 doesn't work because I upgraded to 2.4 and the new libzfs doesn't line up. If libzfs contained the 2.3 and the 2.4 versions of the symbol and the linker took care of it, would that solve the problem? Or is that just making the library a god-awful mess to maintain forever just to maybe solve that problem some of the time for some people?
that would solve a problem. That would solve an ABI stability problem. I don't think that's the problem that people have necessarily. So one of the things with libzfs is it has a lot of stuff in there that is very much tailored to how the command line tools want to work. Like, it has stuff in there for capturing signals. It has a whole bunch of stuff around errors. It has its own concept of like it has these pull handle, data set handle things where it tries to cache certain kinds of information so it doesn't have to round trip into the kernel. But it doesn't have a sort of a noun verb kind of concept. So it's actually quite hard to use as an API, and I don't think that solves it. The problem
Right. So what people want
in my
is a libzfs a library
lot.
interface to ZFS that looks more like, things I've envisioned before, where you have HTTP-based interface to get input to create data sets and snapshots, rather than, doing exactly what libzfs does, which is just implement the common bits between the CLI, which, are not aligned to how people use it so much as how the command line is implemented, which is not, I just want to be able to manage some data sets in my user space tool that's creating containers or whatever.
Exactly.
So
So we want to manage those conceptual kind of ideas, I think. Yeah, and I'll just I see it hand up there. Yeah, I know you've done a bunch of work with it, but
As a
just kind of
potential consumer of libzfs, I can say that people are willing to put up with the cumbersome API. It would be nice if the library was easier and more pleasant to use. What worries me more is that its error handling and memory management concepts are designed for one-shot command line tools, not for long-running daemons.
this is exactly the
Um,
point.
well, I think would be a sensible kind of best of both worlds compromise if the ZFS command line utility would gain a ZFS serve command, which would just read basically lines of ZFS commands, maybe JSON encoded, and then return the responses, so that you don't have to have libzfs with its internal unstable API or an ABI in your process, but you also don't have to pay the startup cost of running the ZFS command for everything.
Now,
Because if you need to invoke the ZFS command 10,000 times, that's just painfully slow for automations.
yeah, the startup. Yeah, that's not a thing I want. I know what you're getting at. The startup cost for me is not really the issue. It's the
It's also the parsing.
well, it's not
The
the startup
parsing
cost.
of hot replies.
They're not really they're not really the thing. It's each call into the kernel doesn't really remember much about what came before it. So if you are doing a larger composite operation, it starts each one from scratch. Um, and that's not really going to be helped by that in user space, but also that's still kind of a crappy interface. It's something we'd have to support, but it's very like shelly. It's very like sysadmin-y, and I got nothing against sysadmins. But with a programmer hat on, I want to come in. I want to grab a library that feels like the language I'm working in, has clear concepts that I kind of understand. I want to say, where is the class type, or where is the object for snapshot? Okay, great. Oh, where is does it? Great. So I get a handle on my file system, and now I say, set property, set property, set property, and I don't, or whatever, and I don't have to. I don't have to think about. It works and acts like my language. Is
So
Yeah, and doesn't
you
do
could
things
build-
like
one
you
of
can
the
get all the properties even though I didn't ask, just because I opened a handle.
Yeah, but maybe it can be smart. Like, there's lots we can do. But that's where I usually come to when I looked at libzfs. I was like, this is not for people. And should never be. Like there is always going to be a need for something like it for the command line tools. So like we could reclaim the name. But yeah. So the other just to round out the survey. So the last tool you kind of have left once you get to that point is channel programs, which is for people who haven't seen it, this is a little bit of you can run the command ZFS program to load a little Lua script into the kernel. We have a Lua interpreter in there, and that exposes a Lua API that can do certain operations like creates snapshots and destroy things and whatever. Some of the nice parts about that is like it will do it all on a single transaction, which is not sometimes, but not always easy to arrange from inside from the ZFS tools. But also that API is not well fleshed out either. And you are limited by things like it has to run very, very quickly because otherwise it gets killed. Because you don't want to have a program that runs forever or runs away and eats all the memory inside the kernel. So it's got some very strict limitations on it. It also just, personally, I just feel unsettled having an entire Lua interpreter inside the kernel. Especially, so that's kind of some kind of summary of the blog post, which is just surveying what we have. And yeah, my sort of contention has been, however we do it, we need a programmatic interface that is good for programmers to use and also does all the job. But and that's what I have a couple of prototypes of things like that. But maybe, depending on what people need, maybe it's better just at least at the start to fill out libzfs core, since we do say that's the thing. And then I have a whole bunch of opinions about about channel programs and about the ioctl interface and about a bunch of stuff, but I'll save those for the moment. That's what we got.
Are there libzfs core users and consumers in the room? Has it been the smashing success? Yes, sir. Let's welcome Andrew. How are you?
Well, we use libzfs pretty heavily. I do think a lot of people who want to use libzfs don't realize they can, I've had people ask before about a Samba module I wrote to get snapshots. We're using libzfs there, but when you're using Samba, you can actually just use the ZFS snapter to get snapshot information. And I think that's probably a lot better way for getting lists of snapshots if you don't want to have libzfs built or trying to write a tool against it. We have a Python module we've written around libzfs. If you want something more full featured in ZFS proper, it's our Python modules written in using the Python C API, and we can provide something that's, in theory, I guess, probably depends on how Chris feels, but we can provide something that's more useful for people that just want to write a quick script to create snapshots and manage ZFS. I think Python's pretty easy for people, and we actually have documentation for it, which is useful. Just a thought of people actually interested in expanding the Python availability of libzfs.
It was described as a handshake agreement and with some certain uncertainty around it. Has that changed? Was that never true and that was just a myth? Or how would you describe it?
Handshake agreement about what?
The API stability,
Well, if we're building a Python library and when people build ZFS, if we distribute it as part of ZFS, that would be simple. We just keep it in sync when you're making changes.
Yes, I think the point here is that if you have a higher level library interface, you can commit to that interface and still leave the actual, kernel user interface completely flexible and able to be broken as needed. Because the higher level interface is mostly not going to depend on those details of what exactly you're, shoving into ioctl.
And when they are, because you're distributing the Python wrapper with libzfs, it'll be the one that matches. So it will have the new argument that got added that would break an application that was trying to directly use libzfs because the API changed. But as long as this abstracted interface is matched to the version of ZFS you're using because it's distributed with it, you wouldn't have that problem. It's kind of the same idea of, maybe overusing the term, but making libzfs a private library in FreeBSD means that it's only used by other tools that are part of FreeBSD, which know they will always be the same version as that version of libzfs. So, when BECTL uses libzfs, the version of BECTL that would be incompatible with a different version of libzfs isn't going to be there, right? It's always going to be the version of BECTL that's compatible with the version of libzfs that shipped with the version of ZFS that shipped in FreeBSD. And when you upgrade, all of those will change atomically at once to the next version and all work together. But, with Delphix's appliance, when they were using libzfs directly from C, if every time, we added an extra argument to a function, it blew up their entire appliance and they were like, can you not place? And so, yeah, if part of that is, libzfs core getting bigger and being, mostly just that thin wrapper around the ioctal, but handling that slight differences between, we added an extra field to the struct or whatever. Most of the ioctals now, I think, are NV-less and are a little less persnickety about adding moving fields than when they were raw structs. But yeah, it really depends on the use case. And I think having something that's more like what the consumer wants would be useful. But I don't know that any two consumers end up wanting the same thing. But like enough people make appliances on top of ZFS that I think creating and managing data sets via a library could be all the same in all those cases. It's just, I don't know that anybody's kind of written a specification that we could try to work against.
Historically,
The problem is that there is no library to build upon for someone wanting to write this nice high-level abstraction, because the only place where the necessary types are declared to even invoke the ioctals correctly without just copy and pasting it out of the OpenZFS repository is in libzfs, not libzfs core. For example, libzfs core, in my opinion, should not be used to do anything which should show up in the zpool history, because it lacks the ability to append to the zpool history. So even creating a snapshot, which is possible, you cannot log that to the zpool history through libzfs core right now. The types required to do that are in libzfs, not libzfs core, and there's no internal symbol for it either.
the way that the zpool history works is its own tire fire, and I would rather redo the way that works so that it just works with libzfs core, because there's no reason it shouldn't. Yeah, because like right now, it takes the return value, sends it back to userland. It decides whether or not it is allowed to be logged in the kernel, and then the user requests to log it anyway, and the kernel can decide to override it based on whether or not it believed it was a failure. It's horrifying. We should just redo zpool history, and then libzfs core would be closer to parity for a first class status.
And the boot environment control command BECTL in FreeBSD, for example, doesn't write to the pool history itself. That you only get the history if you run zpool history dash, what is it, L or I?
I for internal.
Because yeah, exactly, I. And because the ZFS command, zpool command, obviously just concatenate their command lines with spaces to a single string and append that to the history, which kind of makes sense. But for a higher level command, you probably want the equivalent ZFS command invocations in the pool history, so it looks like as if you had done it ahead.
That would be confusing.
Or at the very least, you want the BECTL command to go in there with its command line. I assume it was overlooked when the command was written, because the ZFS command has some logic out of the way to decide if this is something which goes into the history, and then do it the concatenation into a buffer, log that buffer to the pool history, and then do its normal work. So it's far away from where the actual commands are implemented. So I assume when the BECTL command was written, this was just overlooked because there was no example which was easy to find to learn from, which, that's what happens.
Or just I did a bad job mentoring my GSOC student.
And then I'm not placing blame with anyone here, just ascribing this.
As far as the committed versus non-committed kind of interface things back from like the Sundays and still in Illumos,
you can absolutely depend a committed interface on non-committed stuff, as long as you're making what you're doing when you do that is you're making the commitment to update the committed interface to match the non-committed stuff it's depending on. So that's exactly what you're saying.
Yeah, but right now in FreeBSD, you're missing 6 files to even build against libzfs and 2 to build against libzfs core without having the kernel sources checked out. So FreeBSD installs the libzfs header and the libzfs core header, but you can't build against the shared library with the header because the headers included from the library headers are missing. Something like the AVL tree implementation. And some of the other headers are part of the Solaris personality and user space, which is a disgusting set of C macro programming hackery, which is why I understand that this should not be available for accidental inclusion. But also not installing them makes installing the library headers worthless. So it's an oversight that we even got it to this state in FreeBSD, in my opinion. And just not installing the headers would make it strictly worse, in my opinion, even if it would then be ideologically pure. Putting the library somewhere in user include private OpenZFS would it not be clean, but it would be safe enough. It would improve the
But as a
state for users.
consumer of libzfs, do you ever actually need the AVL stuff? Like how much
Yes,
this is
because
actually just header
lot of
solution?
it gets
You have to create
included
the
from the headers. You
callback and
can't
so on.
build against it otherwise. It just says missing symbol, whatever, or missing type, that or that.
Because it wasn't meant to be an interface you'd be using generically, but yeah.
I know that it wasn't intended to be used without those. But having the headers installed, but having them depend on headers which are not installed is obviously not intentional, I would say. This case was never really tested because you weren't supposed to make use of those headers, right? Because it's not a stable interface, it's an internal implementation detail of OpenZFS. But it's also the only interface you get if you want to programmatically talk to ZFS from user space without, for every single operation, forking and executing in command every time.
So, yeah, look, I think at this point, like we all understand that what's there is not fit for many purposes. So, I guess one thing is we've been talking about this for, let's say a year because it was at last year's summit, and for me, it feels pretty much like there's not really probably a lot more to say. At this point, it's just, the work has to be done. It's like, yes, we could flesh out an API further. I don't think there's any particular controversy. I mean, there's no like, libzfs absolutists in the room. It's not a one true way thing. It's just going to be someone has a tool in mind, someone writes the thing, and off we go. Like, is there a consensus that needs to be reached here? I'm not sure.
So if someone were to write a libzfs for humans wrapper and were to propose this for, please include this in your operating system distribution of ZFS so that we have a stable higher level interface, which would probably look like the Python interface ported to C memory management. So callbacks with context pointers and so on. Would there be a willingness to accept this instead of, oh, we really should one day eventually in a far away re-architect libzfs?
Well, I don't think anyone is saying we really should far away do anything. I think it's simply like we more or less know what needs to happen, but it's time equals money. So it's like, I mean, I don't know. I don't feel like I lack clarity in this area. I know exactly what I want to build. I have a couple of prototypes on the bench, that, are only like 10%. So it would take me a long time to bring them anywhere, but it's just like, it's just got to be done now. At some point, I'll decide that I want to write my ZFS dashboard properly, and it won't use any of the libraries we ship with. It'll use code I wrote myself that hits the kernel, and it'll be great. But maybe that'll only happen in 5 years because I'm tired. I don't know. I'm trying to bring this. I would really like to bring this topic to, if not a conclusion, just some understanding that this is the next step. This is the thing we are stuck on.
So I'm hearing two different. I'm not hearing it. I'm barely following you guys. I'm having a hard time. But looking at your article, I'm seeing two main sort of destinations that are desired. One, you mention a whole bunch of, were they pull requests or feature requests or something? 100 possible pull requests, all used to instruct OpenZFS to do things outside its normal storage operations. So, like, my first thought is how many of those do we kind of want to bless and give a man page or a paragraph in a man page, and just have a command line tool and make sure that they're idempotent enough that there's a chef plugin or a salt plugin or whatever, so operators can operate them safely. And they've got JSON interfaces and just it's boring. And then how much is I need to be able to do lightweight prototyping with Lua and Python or some scripting language. And I don't know what I need, but I know I'm going to need more flexibility than a bucket of command line tools that have been thought through enough to get man pages. Is that sort of the
I think that's a really good question. I think that's a good framing.
Okay.
And I know, I mean, I'll let Jan speak to his own thing if he wants, but I know it's kind of part of he's got a sort of, his system involves some amount of using the ZFS syscalls, the ZFS command line tools, and some amount of channel programs. And some of that is that the channel programs effectively do multiple commands on a single transaction. Not quite, but that. And some is that channel programs do that, but they don't have access to everything. So he kind of has this interplay between, but I get the sense he's probably not really tied to one thing or another. So if you could just have one thing that would do a more performance thing or a more atomic thing or a more expressive thing just in one place. So it is sorry, go. Someone's yuppie.
So atomicity would make it easier for me as the tool writer because I wouldn't have to assemble the intended semantics from multiple idempotent operations and wouldn't have to handle cleanup and so on. Because if I could go atomically within a writing sync ZFS channel program, do it all, that would be very convenient because the system would go from one target state atomically into the next, which would be ideal from the user experience in failure cases, but okay. I don't need that. I can automate around that. My use case is I want to specify how a jail should be assembled from a current ZFS dataset, which represents the whole jail, and then its individual mountable file systems are either long-living data volumes, which are not automated, upgraded, and so on, and read-only clothes, which have to be made writable to create empty directories for mount points and then made read-only again, so that I can have immutable infrastructure automation for my jails. And I've prototyped that in shell with the clone updating mechanism implemented as a 3-stage pipeline of a shell script invoking a 500-line channel program. Okay, most of that is comments, but still. Which then returns a list of operations to converge to the specified code. Specified state. I gave a talk on that at your BSDCon. Whoever is looking at here. First day, first slot,
We're looking.
hall D2. And I will make this automation scripts available. But basically the structure is there's a shell script. It takes the jail configuration. It runs the channel program. The channel program tells the shell script which list of shell functions to call because the channel program API is rich enough to figure out what has to change. It's not rich enough to do the changes because I can create those snapshots. Thanks to Rob's new feature, I can create new clones. I can't create new empty data sets from scratch. And I cannot modify non-user properties from the channel program because the setprop function only works on user properties. Because non-user properties potentially have side effects for some of them, and so none of them are usable. Like that. And because of that, this 3-stage pipeline approach is needed. With all of that, I have gotten the time to deploy a jail from just its jail configuration in a pool down to less than 800 milliseconds if you have a modern laptop.
Sounds like expanding channel programs might be the way to go for this. I still struggle to understand what we can't do with existing tools. Like libzfs is pretty good, at least for everything that I wanted to do. Yeah, if it's missing stuff, then maybe we should work on existing tools and expand those.
So libzfs can do everything I needed to do. But it's kind of not made available because basically as a user, I get the impression as an operator, I'm not supposed to code against that.
I was specifically referring to libzfs.
Oh, okay. The reason is I would have to write my tooling in Python then. And I wanted to write my tooling in C.
I think
This
one
final version of it.
other thing worth noting is that, as users, when we talk about libzfs, we don't literally necessarily mean libzfs. We just mean some kind of programmatic API that we can use to interface with ZFS.
Right, and I think kind of to Rob's point earlier, having that interface have a little more contextual awareness and the ability to do an operation and then do a second operation, knowing what has changed the first one instead of, the way libzfs works now is because it's meant for all these one-shot commands. When you open a handle, it gets the properties and does some things and then closes. And so it means if you run 3 commands in a row, you get the properties of the whole pool 3 times. And, it's a bunch of actuals you didn't need to be doing. And so having to be more context aware and able to kind of reuse information we just fetched instead of having to go get it again can be very useful. But yeah, I think this ends up looking like a different library or a large expansion to libzfs core, where you have this more kind of verb-based, or like we talked about a bit, maybe something that looks more webby, to just express what you want to get created, what data sets you want to create, what snapshots you want to create, how you want to change them, rather than libzfs is just kind of an implementation detail of the command line. But I mean, to Alex's point, like without a very specific list of what it needs to be, it's kind of just wouldn't it be nice and not a thing that we can build?
Are there consumers of ZFS who might be vendors or otherwise who could use a better non-Python, needs a better name, libzfs asterisk?
Well, I assume most of the ones that are building some kind of web interface, the Python one is fine. And that's why, like, they needed it, so they created it, and that's why it exists. And I think, to the point, like, if somebody has that strong of a need for a nicer interface to ZFS via a library, then please build it, and we'll be glad to include it in the repo.
Is the plumbing there?
The people who need it will know what it needs to do better than we will.
Is the plumbing there for the Python one to be joined with a, bad example, Perl one, other languages, or is it just a tight integration of Python and ZFS?
Especially for FreeBSD, it would be
That's going to 10,000 flowers bloom
pure.
based on that model.
I mean, you should be able to build one based on whatever your favorite language is. The issue is going to be supporting them, right? So they want to end up with one thing that we can actually reasonably support in the repo. And right now that's PyZFS, right? And then libzfs to some degree. Obviously, there's some issues there, but yeah, we can't really provide, one for every language out there. But
And the sort of interface that's going to be idiomatic for different languages, it's going to look quite different. The one you build that's idiomatic for a Rust programmer is not going to look anything at all like what you build that's that's idiomatic for a Ruby programmer.
I mean, I think so long as you have good semantics around object life cycles and you have one scripting language using a swig binding, we can figure it out. I don't really want to maintain a swig Ruby wrapper again, but my life takes me where it takes me.
But Jan's use case is in channels for the majority of. Is that a correct statement? What?
Do you want to be on mic? And Rob did pre-context add a feature or two that you can describe on the stream to meet some needs on channel programs where I forget what it was.
I guess stupid question is, what wouldn't be solved by adding more missing bits to channel programs, especially as Jan said, that it avoids the need for the consumer to have to do their own cleanup if a group of operations does not succeed somewhere in the middle, right? If you're doing 4 operations and the third one fails, you don't want to have to go and unwind the first 2 yourself. If you did it as a channel program, it either completed or didn't.
My use case would be fully covered by a slightly richer channel program API.
So make a wish list of what channel program APIs you need, and maybe we can get there.
Setting properties and creating fresh file systems.
And I believe set properties during creation of new data sets, as I recall.
Doesn't really matter.
Okay.
I can do it in the channel program, create with default and then set.
Did you get snapshot creation? That was one of the earliest operations of it.
Snapshot creation always existed.
Yeah, what did Rob
That
add?
was one of the initial features. Clone creation was recently
creation,
added by Rob Norris.
Thank you, Rob.
For that.
Okay.
So,
Any final closing thoughts, especially from other voices who have not chimed in this last hour? That said,
Sorry. I do know that, early on you had mentioned the idea that a lot of people would have of having a very, what is it, webby kind of interface for it. Yeah. Yeah, I think that a lot of people would very much like that if that can be achieved somehow. As a security hole. Yeah, but you can apply it.
Because we don't on an actual web interface, we just mean an idiomatic interface that's like, I would like to do CRUD on data sets and snapshots and so on. Yeah. Just be...
the JSON RPC service or what?
if you were to apply it on just like on a local Unix socket, and then okay, now I have a Unix socket, now I can put security stuff in front of it and get access to it that way, then it's now not ZFS's problem.
As long as that's auditable for who you what way. Got to everything else.
Back to that's my problem.
History.
If it just worked out in Bureaucracy, so start the current part doesn't, it could be sorry on why.
Well, thank you, everyone. Let's just close it there and let the conversation continue in parallel elsewhere.